when I had the class flip coins, flipping 4 coins and recording the heads and tails in a specific order, 4 different coins, penny, nickel, dime, quarter. So it was the heads, then the nickel, then the dime, then the quarter. When we compile those results to determine whether we have 0, 1, 2, 3, or 4 heads, different people had different results. The first person had 0 heads twice, 1 head 10 times, 2 heads 12 times, 3 heads 6 times, 4 heads 1 time. And that was a total of what? 12, 24, 30, 31 flips. Okay, the second person had a total of what? 21, 25, 26 flips, if I count that right. Never got 0 heads, got 1 head 14 times. Now, out of 26 flips, that's a fairly unlikely occurrence. And it could be that I heard that wrong. Maybe that's really a 4 instead of a 14, but we're going to accept that for the moment. Nobody corrected me on that, and somebody did correct me on a couple of these numbers. They actually said them wrong. It's more likely that I'm going to hear them wrong, and I might well have heard that one wrong. But anyhow, 0, then 14, 7, 4, and 1 for the 0, 1 through 4 heads. We can see what happened to the third person and the fourth. When we total these up, we find that no heads occurred 10 times, 1 head 31 times, 2 heads 33 times, 3 heads 26 times, and 4 heads 13 times. Now that's out of, these add up, what, 10, 41, 74, 113. Yes, the number I had in mind. I wanted to add it up again to make sure. Out of 113 trials. So that the 0 heads and the 4 heads, as it's going to turn out, occurred a little more often than we might have expected. But this isn't a totally unreasonable result. Okay, it's a little out of the range of what we would expect, but it could certainly have occurred this way. If we graph the histogram, for 0 heads, we have 10 occurrences. So we could say the number of heads is 0, 1, 2, 3, or 4. And we draw a bar that represents 10 corresponding to 0 heads. Then for 1 head, we should have 31. Let's see if and that means that this bar should exceed this bar by a factor of 3.1, because 31 divided by 10 is 3.1. In other words, this bar should be 3.1 times as high as this one. Now, let's see how I did. There's 10, 20 would be there, 30 would be there, 31. That's not unreasonable. 33 for 2 heads, that's just a little higher than the 1 head. We could check that. We could take 1/5 of this bar, which might be about there, and add it to this one and see that that really does seem to work out pretty well. 26 would be 7 less than 33. 7 is about here on the first bar, which represents 10. And if we go that much lower, we get something pretty close to this. 13 should be 3 higher on a scale from 1 to 10. 3 would be about here. If we go 3 higher than this, well, we get something pretty close to this. It maybe looks like this might be just a little low. And also 13 is half of 26. So if we take this distance and stack it on this distance, that does lead me to believe that one's just a little bit low. So that we don't have complete 100% consistency in this histogram or bar graph. There's a difference between a histogram and a bar graph, and I'll let you worry about that. I'm not going to get that picky on terminology. In any case, this represents pretty much the histogram that comes from what we actually did. Now, I asked everybody to see if they could list all the possible results if you flip 4 coins. Okay, and people did. And nobody, I think, got the 16 results that are really going to occur, 16 results that are possible when you flip 4 coins. 2 to list them, we need to be systematic. And if you haven't thought through this, you probably ought to stop and think through it and see different strategies for listing these possibilities. Okay, so one strategy that somebody came up with in class was to do first all heads, and then second all the occurrences with just one tail. So we started with heads, 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 and then we did heads, 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 tails, and then we migrated the tail to the third position, the second, and the first, and right away we have 5 results, and that's all the results that can possibly happen with no heads or with no tails or one tail, that is with all heads or 3 heads if you want to look at it that way. And I made the comment in class, and it turns out to have been false, and I found that out as I was listing this, that, well, okay, just go ahead and list everything up to 2 tails. In other words, after you've done all heads and 1 tail, do the 2 tails, and having done that, then you can just change all your heads to tails and tails to heads, and you'll get all the rest of the possible results. It turns out that was a fairly ignorant thing to say, but my heart was in the right place. If there had been 5 coins, that would actually have worked. Any odd number of coins, that strategy would have worked. I went ahead and started listing. Okay, I've listed heads, heads, tails, tails, and then I took this tail and moved it over to here, and then I took this tail and moved it over to here. So I was kind of migrating the tails as slowly as possible to the left. Having done this one, I had no choice but to put a tail first, and then we can see that I got the other possible results. Put the other tail at the end, then second to the end, then third to the end, and then that completes all the possibilities for 0, 1, or 2 tails. Now then I got down to about here, and I said, well, there are more of these, and I'm up to too many because I know there are 16 possible outcomes. How am I getting too many? And it becomes clear that if I reverse the heads and tails on any one of these, I get another one of these that I've already listed. For example, if I reverse the heads and tails here, I get this. Okay, and that's just from the fact that there's an equal number of heads and tails. When I get down to the occurrences that have equal numbers, there's no reason to be reversing the heads and tails. I will have already listed them. Okay, so anyhow, then I complete that strategy, and we get to 16. Here, just one, and I wrote a false instead of a tail. We do something very much like this in listing the logical possibilities of true and false, as you'll see very shortly. So I just kind of did the false there. Okay, well, anyhow, we see that that's one strategy, and that's a good strategy. Another strategy is a tree diagram. We start, our first flip could be either head or tail. Our second flip then could be either head or tail. So if our first flip is head, our second would be either head or tail. And if our first flip is tail, our second flip could be either head or tail. So in the first 2 flips, we could have head, head, or head, tail, or tail, head, or tail, tail. Then on each of those possibilities, on the third flip, we could have either head or tail. So we see that I put a head or tail at the end of each of those branches. And then on the fourth flip, the same thing. And we see then that there are 16 possibilities. Heads, 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 tails, which is the same as this one. Heads, heads, tails, heads, which is the same as this one. And heads, heads, tails, tails, which is not the same as this one. We're going to get a different order in our listing if we use the tree diagram, but we're going to get the same results, just in a different order. Another possibility is to list them in alphabetical order. And it's going to turn out that alphabetical order is going to mimic what I got here. Since I listed head before tail in each case, wherever I put the head and tail together, or wherever I added a head-tail possibility, it follows pretty immediately that the listing is going to have to be in alphabetical order. So in alphabetical order, first all heads, Then we got to throw tail in here, throw that at the end, or throw it here. And then after doing this, instead of putting a tail here, that would get me out of alphabetical order. I've got to keep this tail here as long as possible, so I get a tail, tail. And then I'm left with no choice but to put a tail here, tail, and so forth. So you can see that we get an alphabetical order, and if you follow an alphabetical order, you will find that this is the way it works out.